Hello, this is Mrs. Taylor, and I would like to pick up where we left off with derivative rules today in class. So, the example we left off with is it said find an equation of the tangent line to the graph of f of x equals x squared when x equals negative 2. And so what we learned today is we can use the power rule to find the derivative of x squared. And if we plug in negative 2 into that derivative, I can get the slope of the tangent line. So the derivative of our f of x would be f prime of x and equals, and then the power rule says you multiply by the exponent, so times 2, and then you subtract 1 from the original exponent, and 2 minus 1 is 1. So our derivative would be 2x. And then when I want to find the slope at x equals negative 2 to create the equation of the tangent line, I would evaluate f prime of negative 2, which would be negative 4. So that's my slope, but I need an equation, so I need a point. Well, I know x equals negative 2, but I got to know what the y value is. So I would evaluate f of negative 2, not f prime, to get the point, the y value, which would be 4. So now I have everything I need to make the equation of my tangent line. I have my slope and I have my point, negative 2, 4. So using point slope form, I would say y minus y1, which we said was 4, equals m, the slope, which is negative 4, times x minus x1, which was 2. So that would be, or excuse me, negative 2. So make that plus 2. And so that would be the equation of my tangent line. Alright, the next rule is the constant multiple rule. It states if f is a differentiable function and c is a real number, then c times f is also differentiable. And the derivative of c times f of x with respect to x equals c times f prime of x. So all this is saying is if I have some constant that the function is being multiplied by, I take the derivative of my function and carry that constant over. So in other words, if I work out this one, find dy over dx, or the derivative of y with respect to x, of y equals 4x to the fifth. So according to this, I can take the derivative of x to the fifth and then just multiply it by 4. So it would look like this. 4x to the fifth, the derivative would be 5, or excuse me, take that 4 and then multiply by the derivative, which would be 5x to the fourth. So 5x to the fourth. And of course, when I multiply that out, 4 times 5 is 20. So 20x to the fourth. So that would be my derivative here. So dy over dx would equal 20x to the fourth. dy over dx, derivative of y with respect to x, equals 20x to the fourth. So looking at a few examples here, in A, I have y equals 2 over x. Remember, x is on bottom, so as an exponent of negative 1. So multiply by negative 1, subtract 1, and the 2 carries over. So it would look like this. When you subtract 1 from negative 1, you get negative 2. So it would be negative 2 over x squared. And then here, my constant would be 4/5. So multiply by 2, subtract 1 from the exponent of 2, and you get 8/5 t. Square root of x would be x to the 1/2. Multiply by 1/2, subtract 1 from the exponent, and you get 2 times 1/2, which would be 1. And then x to the negative 1/2 would then move to the denominator. This one looks very involved, but if you realize that the cube root of x squared is just x to the 2/3, and this 1/2 is a constant, and so you could change it to 1/2 x to the negative 2/3, multiply by negative 2/3, subtract 1 from the exponent, and you get negative 1 over 3x to the 5/3. And lastly, I have a 3/2 times x, multiply by the 1, that is the exponent of that x, Subtract 1, you get x to the 0, so you end up with just negative 3 halves. So remember that parentheses are our friends. So in this case, we have 5 over 2x cubed, and it may be easier to rewrite it as 5 halves times x to the negative third. And then you would differentiate and multiply it out. For b, remember here, it's the same setup, or excuse me, same numbers and variables as a, but these parentheses mean something very different here. It would be 2x cubed, so you'd have 2 cubed and x cubed, which makes it 5/8. So keep that in mind, that the parentheses are important. You have to pay attention to where they're placed. For c, this x to the negative 2 should be pulled out as separate from the 7/3. And then remember, if it's a negative in the denominator, you move it to the numerator and make it positive like they did here. Take the derivative, multiply by 2, subtract 1 from the exponent of 2, and you get y prime equals 14x over 3, or 14/3 x. And then similar thing here with d, where the parentheses are now around 3x, so that means that 3 is being raised to the negative 2 as well as x. So 3 to the negative 2, well, 3 squared is 9, and it's negative, so it moves to the numerator, so 7 times 9 is 63. And then x to the negative 2 would move to the numerator. So you just end up with 63x squared, which makes this a lot easier to find the derivative of. The sum and difference rules of derivatives. So the sum or difference of two differentiable functions is differentiable and is the sum or difference of their derivatives. So if I have f of x plus g of x, I can find their derivatives separately and just keep the addition or subtraction symbol. So here we have f of x equals x cubed minus 4x plus 5. And according to this rule, I can take the derivative of each term individually and then bring it all together for the derivative. So it would look like this. The derivative of x cubed is 3x squared, derivative of negative 4x is negative 4, and the derivative of 5 is 0. Same thing for g of x and b. 1/2 would be your constant, negative 1/2. So when I multiply by 4, I get negative 2, subtract 1 from the 4, and you get x cubed. And then 3 times 3 is 9, subtract 1 from the 3, you get 9x squared. Negative 2x, the derivative is negative 2. Similar setup here. The derivative of x cubed will be 3x squared. Derivative of negative 3x will be negative 3. And then here, the derivative of negative 2x to the negative 4 would be 8x to the negative 5. So f prime of x would equal 3x squared minus 3 plus 8x to the negative 5th. And you could rewrite this as a fraction, 8 over x to the 5th. Either would be acceptable. Last thing, derivative of sine and cosine. So these are ones you just have to memorize. The derivative of sine is cosine, and the derivative of cosine is negative sine. So the same rules that we just learned, constants and coefficients and sum and difference, apply to trig. So for a, this 2 is being multiplied by sine of x. So I could take the derivative of sine of x, which I know is cosine of x, and just carry the 2 over. So y prime would be 2 cosine of x. For b, remember, if I have a function over a constant, I can pull that constant out as a fraction. So this becomes just like a, but with a 1/2. And then for c, this is the sum and difference rule. So I can take the derivative of x, I can take the derivative of cosine, and then just write it out. Lastly, your problem set out of your textbook that relates to this is page 115, number 3 through 54. I know I went through these rather quickly, but because it was on video, you can go back and rewind and pause as necessary. But these are the derivative rules, and tomorrow you will have your quiz and also some practice problems with these rules.